So this is a screencast on how to deal with a problem from class where we come up with this x in the denominator. The strategy, I'm going to replace this fraction here with something that I know is definitely bigger, and I'm going to prove that that bigger thing is less than epsilon. And the way I can make a fraction bigger is I have two options. I can either make the numerator bigger, but I like the numerator, so I'm not going to do that, or I can make the denominator smaller. So I'm trying to figure out what the smallest thing absolute value of x could be. And what do I know about x? Well, x comes from here, so x is going to be between c minus delta and c plus delta. And just ignoring the fact that c, the absolute value, basically I'm going to assume that c is positive for right now. The picture looks like this. Here's c. I'm going to make sure that c minus delta is less than, or is bigger than c over 2, which means my x is going to have to be, somewhere in here, which means that the smallest value x could possibly be is c over 2. So that's how it works for positive. I'm going to make sure that delta is less than or equal to c over 2. And very similarly, if c is negative, then the picture looks like this. Here's 0. Here's c. Here's c over 2. And here is 3c over 2. And the idea here is here's c plus delta, and here's c minus delta. And my x, right, over here I knew that my x would be living basically in here, so this is definitely smaller. And here my x would be living somewhere in here. So now I have 3c over 2 is actually smaller, but this actually isn't a problem. Because I don't care about x, I care about absolute value of x. So if I take the absolute value of everything, this becomes, well, 0 is over here. C is now absolute value c to the right. And notice it's just going to flip. I'm going to get absolute value of c over 2. This is not to scale. Absolute value of 3c over 2. This is going to be absolute value of c plus delta. And here's absolute value of c minus delta. But regardless, I know that absolute value of x is going to live in here. So in either case, x is going to be less than c over 2 if c is positive, which means that it's equal to c over absolute value c over 2. Or if c is negative, I'm going to get that absolute value of x is going to be bigger than absolute value of c over 2. So I don't actually want to make this. If I do this all in one step, I can just say, so I can make delta less than or equal to absolute value c over 2, and it works for everything. And then what effect does that have? Oh, and so just to write myself a note, maybe I'll do this in green, I'm going to let delta be the minimum. So if delta is the minimum of this and something bigger, I choose this. If delta is the minimum of this and something smaller, I'll choose the other thing. So this basically guarantees, if I write this, I've partially defined delta. And I haven't completely defined it because, right, that's what I'm trying to do basically right now. But I've partially defined it enough to get me past this step. Because then what I can do is I can write that this is less than or equal to, or I can replace absolute value of x with, oh, absolute value of x is going to be, it's going to be bigger than absolute value of c over 2. So I can just replace that there. And then times c squared. Oh, but this is less than or equal to delta over c cubed over 2. So if I want epsilon, I can just pick the rest of my delta to be, well, I need an epsilon, and I need to cancel out the c cubed over 2. So whichever one's smaller, we'll take. And so this is, right, this is equal to epsilon, so I can just cross that out. And that's it, we're done. So the whole process is we want to replace this with something smaller. We could do c minus 1, but then we've got two problems. If c equals 1, we have a problem. And also, if c is negative, that's actually going to give an absolute value that's bigger. So that's how we do it, c over 2.